All right, so I'm going to go over how we can graph quadratic equations in vertex form first, and then standard form, and then I'm going to show you some techniques as well. So here we have vertex form, which is essentially this form, where we have f of x is equal to a times x minus h squared plus k. The vertex in this form is located at h comma k. So in this equation, our h is 3, because remember, it's minus h. Their vertex is 3, comma, and whatever this number is, in this case, it's minus 4. So the vertex is at 3, comma, negative 4, which will be right over here. Now, the vertex, remember, is like the middle of the graph. So our axis of symmetry is going to run through this. And so this will be the axis of symmetry, this dashed line, which will be the equation x equals 3. Axis of symmetry really helps you graph your parabola quickly and helps you make sure that you're graphing it correctly. And the general basic technique when you want to graph these is just to plot a couple of values on one side and then reflect them on the other side. So for example, you can make an XY table just to organize your points. And so picking 3 from the left, 1. So if we go from 0, 1, 2, the vertex is already at 3, negative 4. So we go 1, 0, 1, 2, 3, 4, 5, 6. So we just plug these values in to this equation and then reflect them onto these ones. So for example, plug 0 into this equation. So I'll do a couple of them by hand. We'll get that. Let me use a different pen so it's not messy. So we go y will be equal to 0 minus 3 squared, or negative 3 squared, minus 4, or 9 minus 4, which is going to be 5. We're going to put 0, 5 there. For 1, we're going to plug 1 into here. So we'll go 1 minus 3 squared, so negative 2 squared, minus 4, 4 minus 4, that'll be 0. So we'll put 0 here. And then 2, we'll get y is 2 minus 3 squared. Let me just do it together. 2 minus 3 is negative 1. So negative 1 squared minus 4. And we get 1 minus 4, which will give us negative 3. So plotting these, 0, 5, 1, 0, and then 3, negative, or 2, negative 3. Part of one side of our parabola will look like this. And then see, you can just reflect these onto the other side. So negative 3 will go here, 0 will go here, and 5 will go there. And then your parabola is going to end up looking like this. And there you go. So let me draw our parabola through those points. The more the better. But you want to have enough so you can get a good idea of what points it's going through and the y and know where the y-intercept and x-intercepts are. So like the important characteristics. So the y-intercept here will be at this point 5 or 0, 5. You can either put 0, 5 or 5. I just like to write the whole point so that students don't get confused or get to overthink it. Y-intercepts or x-intercepts are going to be 1, 0, and 5, 0. This will be a minimum. The vertex will be a minimum because it's at the bottom of the graph. And the domain will be all real numbers or from negative infinity to positive infinity. And the range will go from the vertex upwards. So the y-coordinate of the vertex is -4. So it's going to go from -4 to infinity. Or you can put or you can write that y is greater than or equal to -4. I like interval notation, but either way is fine. Okay, so here's a cool trick that a lot of students are gonna like, but you have to make sure you understand it. With quadratics, you remember you're always squaring values. So let's make a table here. And in this table, I'm going to put A across the top, and I'm going to go A is 1. So let's see. Let's pay attention closely because you're going to like this. In this problem, A is equal to 1 because it's 1 times x minus h. So in this case, A is 1. Now, whenever you have A is 1, your parabola is going to grow by just the squares of like the whole numbers. So in other words, the x values 0 squared becomes 0. One squared becomes 1. 2 squared becomes 4. 3 squared becomes 9. 4 squared becomes 16. And you're like, what the hell do I mean? Like, what does that mean? Well, if you're at the vertex, this is like the vertex. Think this as starting at the vertex, 0 units away from the vertex. You're not gonna go up at all because this is the vertex. But if you're 1 unit away, so let me draw a picture here. Actually, this is the vertex. If you're 1 unit away, so to the right, let's say, you're gonna go up by 1. So think of this as going up by 1. So on both sides, up by 1. If you're 2 units away, 1, 2, you're gonna go up by 4. So 1, 2, 3, 4. So it'll be plus 4. If you're 3 units away, you're gonna go up by 9. Something like this. So let's look at this parabola. I'm going to zoom in a little bit. We started here at -4. 1 unit to the right, we went up by 1. See, this distance is 1. We go 2 units over, it's 4. This distance is 4. 1, 2, 3, 4. If you go 3 units away, this distance is 9. -4 to 5 is 9. If we went 1 more, it would go up by 16. So in other words, if I wanted to just plot the next point at 7, I know that this is going to be this will be at 12. 7, 12. My next one is 25 up, so my next one would be 8, comma 9 more than this, 8, comma 21. But let's look at this next example. So this is where it's going to start helping you. So we have vertex form again. So remember, you want to find the h and k. Vertex form is a times x minus h plus k, or a times x minus h squared plus k. The h is going to be -2 because it says +2. K is 8. So the vertex will be a -2, 8. So put in the vertex, -2, 8. Drawing our line of symmetry, we're going to have something like this. So our line of symmetry will be x is equal to -2. -2, okay. And then now let's make an xy table. So let's go xy. And since we're centered at -2, 8, let's go from the left, -5, -4, -3, -5, -4, -3, -2, 8, -1, 0, and then let's go 1. Okay, now okay, let's see if you can apply our this strategy I was showing. This is kind of not very clear, but I'm going to do it again here. So the a value here is -2. So going back with this table, a value, when a value is 1, our x values grow by, when you're at the vertex, we're 0 units away from the vertex, we go up by 0. When you're 1 unit away, you go up by 1. When you're 2 units away, you go up by 4. When you're 3 units away, you go up by 9. When you're 4 units away, you go up by 16. When you're 5 units away, you go up by 25. Now, so in other words, if a was 1 in this case, we would go 1, we would go down 1 here. Then we would go another 4 over here. And then we would go 9 down. So then it would go down to -1, and so forth. But a is -2 here. So all you have to do is double these values. And this will tell you how many units away to go. So 2 times 4, 8. 2 times 9, 18. 2 times 16, 32. 2 times 25, 50. So then, in other words, when you're 1 unit away, we go down 2. When we're 2 units away, we go down 8. So here we're going to go 2 over, down 8. When we're 3 units away, we're going to go down 18, all the way over here. And then we just reflect these. That's literally going to be your parabola. And then let's just fill in our intercepts. Y-intercept will be at 0, 0. X-intercepts will be at -4 and at 0, 0 as well. So -4, 0, and then 0, 0. Domain, again, is all real numbers, so -infinity to positive infinity. And the range will be from -infinity to -8. All right, next one. Okay, so when you have this form, this is standard form. So here we have f of x equals ax squared plus bx plus c. We can find the vertex by using these equations. X is equal to -b over 2a. So in this case, it'll be b is in 2, so -b will be -2. 2a will be 2 times -1/2. So -2 over -1. This will be +2. And then to find y, we just plug 2 into this equation. So -1/2 times 2 squared plus 2 times 2 minus 7. So -1/2 times 4. So we get -2 plus 4 minus 7. So we get -5. So our vertex is 2, -5. 2, -5. Drawing our line of symmetry. So we're going to have x is equal to 2. Okay, in this case, our a value is -1/2. So that's going to tell us it's going to open downward. It's going to do something like this. Okay, so then, again, you could pick values around the vertex. So we can have, going from, -1, 0, 1. And then after 2, 3, 4, 5, you can plug these numbers in and calculate it. But if you can catch on to this trick, you'll save all this tedious work. So let's look at this. So remember my table, our a value could be was 1 and then 2. But what if it's 1/2? So let's make another a table here. So you get some practice. If again, starting if a is 1, and if we're 0 units away, 1 unit away, 2 units away, 3 units away, 4 units away, 5 units away, 0 squared is 0 at the vertex. 1 squared is 1. 2 squared is 4. 3 squared is 9. 4 squared is 16. 5 squared is 25. But what if a is 1/2? Well, at the vertex, we're still going to be 0 units up because it's the vertex. That's where we start. 1 unit away, we just multiply this by 1/2. We multiply 4 by 1/2, we get 2. Multiply 9 by 1/2, you get 4.5. Multiply 16 by 1/2, you get 8. Multiply 25 by 1/2, you get 12.5. So using this, if I plot my points, starting with the vertex, 1 point over, I'm going to move down just half a unit. 2 points over, I'm going to move down 2 units. So 1, 2. And let me zoom in so you guys can see it better. 3 units over, I'm going to move down 4.5 units. So if I move to over here, 1, 2, 3, 4.5, will be like right over here at 9.5. And then I just reflect these on the other side. And that's going to be your parabola. Let me zoom out. And if you want to just plug these numbers in, you'll see you'll get those same values. Here, the vertex will be a maximum because it's at the very top. Oh. The y-intercept will be at 0, -7. There's no x-intercepts. Domain is -infinity to +infinity. And the range will be from -infinity up to -5. All right, one more of these. Okay, so another tedious one. Let's find the vertex first. X will be -b over 2a. Remember this formula, -b over 2a. So -10 over 2 times -2.5. So -10 over -5. That will give us 2. Y will be at f of 2, so plugging in 2, we get -2.5 times 2 squared, or times 4, plus 10 times 2, so plus 20, minus 7.5. So -10 plus 20, 10 minus 7.5, so 2.5. So the vertex will be at 2, 2.5. So plugging that in, 2, 2.5, right there. Line of symmetry will be this. So the line x equals 2. Okay, now, again, we can make an x-y table. You can go going from -1, 0, 1, 2, 2.5 is our vertex, then 3, 4, 5. Okay, so now you're like, okay, what do we do with this guy? We have 2.5. Well, we can use our strategy on my technique. We have the table right here. A is 2.5. You just multiply, again, these values by 2.5. Just like how we multiply these values by 1/2 to get these, we're going to multiply these values by 2.5. So first we get 0, then 1 unit away will be 2.5 up, or 2.5 down. 2 units away, 2.5 times 4, that'll be, what is that, 8, 10? 2.5 times 9, 18, 22.5. 2.5 times 16, 3240. 2.5 times 25 will be 50, 62.5. You won't have to worry about going that far. But let's look at the first one. So 0, 0, 1 unit to the right, we're going to go down 2.5. So then going over 1, we're going to go down 2.5. That'll be right at our vertex, or right at the x-intercepts. We go over 2 units, then we go down 10. So we go, this is 2.5, 3.5, 4.5, 5.5, 6.5, 7.5, 8.5, 9.5. So then down here at 4, negative 7.5. And then we just reflect these on the other side. And it should look stretched out because remember, this is a vertical stretch. Whoops, this is not a very good parallel there. So the vertex will then be a maximum. The y-intercept will be at 0, negative 7.5. X-intercept will be at 1, 0, and 3, 0. Domain, negative infinity to positive infinity. And the range will be from negative infinity up to 2. Or up to 2.5, actually. Okay, so I hope that helps. Let me know if this strategy makes sense to you, because it's just a technique to kind of save tedious calculations instead of having to always plug the numbers in and compute something out. But I never know if you need me to show you in a different way. But again, just let me know. Let me know if it helps, or if something was confusing. And leave a comment about it. Feedback is always welcomed. And if you haven't subscribed, make sure you subscribe. And I'll see you guys in the next video.